Hello everybody, it's Dan here. I am here to show you some magic around how to do some ratio math from the case study. Now the case study is called Social Distancing in the Midst of COVID-19. Make sure that you read the PowerPoint and some of the instructions. Now what I'm doing actually is I am looking specifically at part 1, which is on the second page of the case study, and I am specifically going to be looking at question number 2. So if you look at the handout of the case study on page 2, to the far right there is a data table called data table 1. We're looking at county versus number of cases versus the 2019 population. Question number 2 is asking you to plot the number of cases in each county per 100,000 residents. Well, the issue is every county has a different population number. So they're trying to figure out what's the rate per 100,000 people. Therefore, they can probably target where the rate of COVID-19 is higher. Therefore, we're going to have to take our population numbers and put them all into a per 100,000 unit. Here's the magic formula. You're going to take specifically the number of cases in the county, each county. You're going to put that over their 2019 population number. And then over here, after the equal sign, is we have X, the unknown, over 100,000 people. What does X represent? X represents the number of cases per 100,000 people. Okay? So you're going to use this formula for every county to determine the number per 100,000 people. Okay? Now, I'm going to give you an example. Here it is. So the example is I'm going to use the first county, which is called King County. In King County, they had, by March 26th, they had 1,577 cases. And then at the time, their population is 2,226,300 people. Mind you, this math is going to get pretty big. So just to give you a little heads up, that's what it's going to look like. So let's do this setup. Again, let's use that formula. So first off, it's the number of cases. All right. In this case, they have 1,577 cases. By the way, I recommend writing these down for practice. Then over here, we are going to have the actual 2019 population, which is 2,226,300 people. Again, we're setting up a cross multiplication ratio problem. We are going to solve for X, and this is over 100,000 people. Okay, so far so good. Now, how do we solve for X? What do? We use the hot dog method, or in this case, you probably use the word cross multiplication. So basically, you're going to take these times these, okay? Let's see what that looks like. Well, I'm going to take 2,226,300 X equals 100,000 times 1,577. I told you these get pretty big, okay? Next step in terms of order is I'm going to multiply rather these two together, okay? So I'm going to rewrite this. $157,577,300 I did not do this in my head, by the way. 700,000. Big, 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 big number, okay? Now, I must get X alone. And the only way to get X alone is I have to get this number away. And to do that, I have to bring it over here via division, okay? So I think in your math class, you probably do something like this. And these cancel out, correct? So X equals 157,700,000 divided by 2,226,300. Whew. Now, off the top of my head, X now is alone. We get roughly 70.8. You know, and we can round this up simply to 71 people. That is your answer. What does that mean? For every 100,000 people, 71 of them have the COVID-19 virus. And that's it. So this is your example. You can use this, practice it. The key is using that magic formula, which I showed you in the beginning, to determine how many number of cases per 100,000 people. Okay? Go after it. You're going to complete it for the remainder of the counties. King, I can't even say these names, Snohomish, Pierce, Island, Cagat, Kitsap, Grant, Whatcom, Yakima, and Thurston. Okay, I will show you another video shortly of how to set up your graphs. Good luck. Thank you.